Welcome to this part of the tutorial where I'll show you how to write the code for a line follower and then burn it onto your Atmega 16. For our convenience and just to save time, I have the code already written. You can see this, the line.c, and I'll open this file. Okay, see, this file opens in what we call is a programmer's notepad. The software that I'll be using to burn and as well as to compile my codes for the Atmega 16 is the WinAVR. Now the version I am using is 20071221. Okay, now you can see here is the code. Before I tell you how to burn it, I'll just show you what exactly the code is. The basic algo for line following I already explained in the previous part of the tutorial. Now I'll show you what exactly it does. Just like any other C code, this code starts with the include files. I'm including two files here. One is the io.h or the input output.h, and the other is the delay.h. Now these are located inside the AVR folder and the util folder. Okay, now why I include these files is that the io.h is the basic input output command for the AVR 16, while delay.h contains the basic functions to generate delays in milliseconds or seconds, etc. Now if I scroll down, you can see that I have certain macros that I've already defined. I have defined a macro called Rbtx. I have defined something called check bit, set bit, clear bit, and toggle bit. Now what these do basically is that all operations in Atmega 16 are directed towards ports or pins. They address a whole byte at a time. But sometimes we need to set or clear just one particular bit of a whole byte. Now this we cannot do as such. For that we'll need certain macros, certain techniques. Now these are those. Next comes in the file is the main function. Inside the main function, as you can see, I have defined something called t-lag or the time lag. Now where I'll be using it, I'll show it to you. Remember that I have set t-lag to 0, and then I do something as ddr d is equal to 0xff and ddr a is equal to 0xff. Sorry, ddr d to 0x00 and ddr a to 0xff. Now what is ddr? DDR is data direction register. Now Atmega 16 has got 4 ports. Out of the 4 ports, I need to define which port or which pin in particular I need to set for output and which for input. To set a port for input, I define its DDR to 0, and to set it as output, I define its DDR to FF, that is I set all of them high. Now I have set all the data direction registers of D to low. That means I am using port D as my input port, while I am using port A as my output port. I have set its DDR to high. Now next in the code I have a while loop. Now this while loop is an infinite while loop. As you can see, it has got a 1 here, so this will always go on. Now why do I need an infinite while loop? That is because I want my line follower to keep following the line always. It's not that it should stop after a specific number of iterations or specific number of runs. It should go on, it should continue. Now for that I have set this infinite while loop. If you scroll down, then you can see I have got some if-else statements here. If you see, the first if statement is that I have used the check bit that I mentioned earlier here, the one of the macros, this one. I'll tell you what exactly this check bit does. This check bit, now in order to use this check bit, remember you have to define the macro earlier. Now this check bit, what it does, it takes 1 byte as an input as well as which particular bit of that byte you want to check, that also as an input. Now this whole thing will return a 1 if this particular bit of this particular byte or port is high. So basically this if statement will be executed only if the second bit, that is the third pin of the port D, is high. Now why have I written pin here? Always remember a thumb rule. Whenever you are using a port as input, always refer to it as a pin, and when you're using it as an output, refer it as a port. So the next part, what I do is I again check for another bit of that particular port, that is port D. I check for bit number 4. So this part of the code will be executed when the third and the fifth bit of port D are set high. Now once these two are set high, what will it do? It sets port A to this configuration. That is, port A has got 8 pins, right? So those 8 pins acquire this configuration. That is, the 0th bit is set high and the third bit is set high. Remaining all are at 0. So this configuration corresponds to the bot moving forward. This happens when these two are high. When will these two be high? When both the sensors are high. So that is the correlation. And why do I have this line here? This line is something called a PWM line. What it does is that, remember this T-lag I mentioned earlier? I had set it to 0, but you can set it to any value. Say you set it to 25. What it will do is that it will set this port high. That is, it will ask the bot to move forward, and then it will wait for some milliseconds before going for the rest of the code. So that basically generates a small amount of delay in your code. Okay, so after that you can see now this statement will be executed only when this, that is, the bit 2 is set high and bit 4 is set low. Similarly, this will be executed when it's the other way around. That is, when bit 2 is low and bit 4 is high, and this will be executed when both of them are low. So the condition when both of them are low is that when both of the sensors are low, that is, it has gone away from the line, it has gone out of the line. So I want it to come backward. So I give it this particular code. As you can see, this thing is the complementary of this thing. So this shows that if this drives the motor forward, this will bring it backward, both the motors. Now when I have one high and the other low, what I am doing is that I am setting one motor in motion and I am stopping the other motor, that is this one. I am setting one motor in the forward direction and I am setting the other motor to stop. Similarly here also. Okay, so that is the basic code. I have already told you what the algo is. Now you can see here, this is the end of the infinite loop, and your code should never reach this point. That is the end of the line. So this is the whole code. It's a very simple code. And now how do we burn it? Before burning a code in WinAVR, what we need to do is first we need to save it. What will I do? I have created a folder on my desktop and I have saved it here. I call it line.c. Okay, now once I have saved it, I need to compile it. In order to compile something, WinAVR needs a rule book. Now that rule book is a make file. Now to make a make file, we have a utility called mfile. Now the m file comes along with WinAVR. This is the make file. Okay, so what you do with it is that you click on make file. See, the whole rule book is already made. It has got all sets of rules that WinAVR needs to compile this, but you need to make certain changes. What you need to do, click on make file and then go here, click the main file name and change this name to line. Remember why? Because the name of my file was line.c and I click OK. So the target has now changed to line. Again, go here and change MCU type. Go to @mega and out of the whole range of CPUs available, select @mega 16. Again here it has changed this, and again go here, go to programmer, and in programmer change this to Pony serial. Okay, now because I'll be burning it using the COM port of my computer, I'll show you how exactly to work with that. And in port, see, in port, my port is COM port 9. In my ports, I do not have a COM port 9. So what do? Let me first save it. Okay, I'll just save as, let the name remain the same, make file, I'll go to desktop, and in desktop I have line follower, and I'll save it. I'll change this to make file, and I'll save it. Okay, now my make file is saved in here. You see the make file. I'll drag this, bring and put it on here. Okay, so here is the make file. As you can see, I've opened it using programmer's notepad. Here is my line.c, and here I've opened the make file. Now if I scroll down, I need to find something. Let me find next. Yeah, so here I have as you can see, AVR dude port is COM1, and need to change it to 9 and then save it. Okay, now this thing is saved. I'm saving it using Control S. Okay, so don't confuse with the shortcuts. Once I've saved this, I go back to my line.c. Everything is ready. Tools, make all, and then you see lots of things happening here. And finally you see this is the happy statement. This says your code has been successfully compiled. Process exit code 0 is successful compilation. There are a lot of things up here. You can see, you can go up to find this. Okay, anyways, I'll just skip through this. Once you have done that, if you come to this, you'll see a host of new files here, and one of the things that you need to look at is this. It's called line.hex. This is the file that you will actually be burning into your microcontroller. Now how will you be burning it? You will be burning it using AVR dude. Now what is an AVR dude? First you need to, AVR dude is something that comes along with WinAVR, and in order to operate it you need to go to command. Now just type cmd in your run window and you will get it. And in order to check if AVR dude is working perfectly, just type AVR dude, and it should show a lot of command and all those things. Now you can see there are lots of commands here. I will show you what are the most important commands. I'll exit this. No, let it remain in the background. I'll create a new text document, and I'll name it burn. What I'm doing now is called making a batch file, and I will name it BAT. Yes. Now what is a batch file is that this executes a number of DOS statements or command statements whenever you run this. Now I'll edit this. It opens in a notepad, and I write my code here, AVR dude space okay, and I need to specify my microcontroller. So I'll just check in here. P part number gives the required AVR device, so I'll type PM16. This is the code for Atmega 16, and then I need to give it the compiler. C gives the programmer type, small c, and I'll give Pony serial. Then I need to specify the port, that is COM9, and after that is the most important thing. I need to tell it what to burn onto the microcontroller, that is the file. I need to specify the file. So for that I will need this one right here, U. So I will U memory type, R means write, read, W means write, file name and format. So I need to write it like this. U, it's a bit complicated. I may commit a mistake. Okay. It's a flash, and I need to write it, and I need to write the name of the file. I need to give the whole location of the file. So I'll come here and I'll copy this and I'll paste it here, and I need to paste it here like line dot hex and I. This I is for Intel. This is an Intel hex file, so just no need to bother about that. Then always remember this, that any folder that you have, always make it DOS compatible. If it is not DOS compatible, that is if you have a space or something there, then it's not going to work. So I just changed the name of the folder. I made it line underscore folder, and I've changed this to line underscore folder. Now this is a very simple thing, but you should remember this. Okay, now I'll burn this. So my device is on, it's connected outside, you're not able to see it right now. Double click this. So this is what it does. It's currently reading. See, first it read the whole thing, and after that it did some checking and something, and now it is writing basically. So it's pretty slow, but that's how Pony serial works. Okay, I'll continue after this is completed. Okay, now the data has been written completely onto the chip. Now it's reading the chip again just to verify that whatever is written correctly. This it does, but this can be disabled manually, but I recommend that you don't. You just need to wait for some more time. It took 55 seconds to write it onto the chip. The larger your program, the more time it will take. So this is a slow process, but you have to do with it. And it's almost done, and that's it. It's done.